Okay, so the idea that we're going to look at for today, composite functions, is that we can combine functions that we already have in a little bit different ways than we've seen before. We've already, whether we realize it or not, worked on combining functions with things like addition and subtraction, arguably with multiplication as well. But I want to start with an example of some ways we combine functions that we've already seen and already used. So for our first example here up at the top, says Peyton is buying produce at the grocery store. She plans to buy some blueberries, which cost $1.99 per pound, and some raspberries, which cost $2.25 per pound. So we can write a function to describe how much her blueberries cost and how much her raspberries cost. Okay, we've done this before. So my cost for blueberries would be that price per pound times however many pounds I buy. Does that make sense? Okay. And then my cost for raspberries is going to look really similar. The cost for raspberries would be that price per pound times however many pounds of raspberries I buy. So for my example, B is my pounds of blueberries, and R is how many pounds of raspberries she buys. So pretty easy to figure out the cost of each of those things separately. But when I go to check out at the grocery store, am I going to pay for them separately? Is that usually how we do our grocery shopping? You pay for everything at once, right? You don't pay for the blueberries, and then the cashier brings up the raspberries and you pay for that, and then they bring up your paper towels and you pay for that, and then they bring up your like bread and you pay for that, and they bring up your milk. That's not how it works, right? You get one total. They say this is what all your groceries cost, and you pay once. So if I really wanted to know how much money am I spending at the grocery store, what would we need to do? How could I represent that? If I wanted to know the cost of both of these things at once, I could add them up, right? I could add up my functions, okay? So I could do, to find that total cost, 199B plus 225R, right? I can add up what I spend on blueberries and what I spend on raspberries. That's my cost together. And then if I asked you a question like, what if she bought this many pounds of blueberries and this many pounds of raspberries? How much money is that, right? What did you spend? We could find that by doing what with these values? Plugging them in where they go, right? So 3 is how many pounds of blueberries, so that's our B. 2.5 is our pounds of raspberries, so we plug that in for R, and we'd have 1.99 times 3 plus 2.25 times 2.5. We get 5.97 here plus 5.625, and I add those up and we get 11.595. Now there is one issue for this particular example with the answer that I got. Why is this not going to work? Yeah, we're talking about money, right? And we do 2 decimals for money. We have to round to the nearest penny. So this would actually be $11.60, right? Only 2 decimal places for money. So in this case, we've done kind of this first example. We've taken 2 functions and added them together to get something a little different, okay? I could also take 2 functions and subtract them. I could take 2 functions and multiply them, okay? This would be potentially give me some distribution if I were multiplying 2 functions together. I could also take 2 functions and divide them, as long as The one on the bottom isn't equal to 0. Okay? Because if it's equal to 0, then we're undefined and we don't want that. So nothing over 0. Okay? The just key is that if I'm doing these operations with my functions, if I'm adding functions, subtracting functions, multiplying, dividing functions, the inputs for each of these need to be the same type of thing, okay? And then the outputs I get from them need to be the same type of thing. So, for example, from our produce example, what's the input for that blueberry function? What kind of things am I plugging in for B? What does that represent? Pounds, right? So the input for our blueberry function is our pounds of blueberries. What's the output? What do I get? I plug in pounds of blueberries. I get out the price, right? The cost. How about our raspberry function? What did we put into our raspberry function? Pounds of raspberries. And then what did we get out of that function? Price. Now, how about that total cost function where I added them together? What was my input? What did I put in? Pounds again. Pounds for two different things, but still pounds. So pounds of blueberries and pounds of raspberries. And then I got out price again, right? The cost. So our inputs were all the same type of thing. Our outputs were all the same type of thing there. What we're going to look at today is a new idea. Okay. So whether we realize it or not, we've done stuff like this before. Total cost, if I'm buying different things, we've done stuff like this before. Okay. What we're going to look at is a new idea where instead of maybe adding or subtracting functions that have the same type of input and getting the same type of output, what we're going to look at is what's called a composition of functions. For a composition of functions, here's the difference. I have a first function, I put in the input, I get out the output. For my second function, when I'm composing, the input is the output from the first thing. And then I get a brand new output. Okay, so that's going to be the difference for today. Turn the page for me. And I want to show you some notation before we get started. Okay, so what we're doing here is creating a new function, okay, by what's called composing two or more. We could do this with more than two functions, but by composing two functions. So the notation I see up here at the top, okay, these mean the same thing. This on its own, we would read as g of x, right? We've seen f of x, g of x, h of x. So when I throw now another function name outside, this is f of g of x, okay? And this we read the same way. It's a little bit different notation, but it means the same thing. F of g of x, okay? They mean the same thing. And what we're gonna do is work from the inside out to evaluate for today at a specific value. So we're evaluating again, okay, with numbers. You can see example 1 up there. It's got some numbers in there. So this will be really similar to what we did at the very beginning of our unit, okay? But this time I evaluate once, and then I'm going to immediately evaluate again, okay? And again, we work from the inside out. So I'm going to work inside and then outside. So our very first couple of problems here on example 1, I could have given you last week, right? This is just evaluate at a given value of x. Okay, so f of 3 means this is my x value, 3 is my x value that I'm going to plug into my function f of x. So this would be 2 times 3 plus 1. We've replaced x with 3. And then we simplify, making sure we follow order of operations. So 2 times 3 is 6. 6 plus 1 is 7. So we can say f of 3 is equal to 7. Again, we've done this already. This is not new. And then for b, same idea, but now with g of x. So g of x is this second function that we've got here up at the top. And we're saying plug in 3 for x, substitute in 3. So this would be 3 squared minus 4. 3 squared is 9. Minus 4 gives us 5. So g of 3 is equal to 5. Okay. Again, this is stuff we did last week. Okay. Here's the new part. Okay. We've got some compositions down here with C and D. So here's what this is saying. Work from the inside out. So inside, we've got g of f of 3. Inside is f of 3. So we're going to start by finding f of 3. Now, the nice thing for us is that we already found f of 3, right? That was A. I know that f of 3 is equal to 7 because we happen to find that already. So now what we're looking for, right? F of 3 is 7, right? This part inside here is 7. So now what I'm looking for is g of 7. Okay, so the output from my first function is now the input for my second function. Okay, and for today, we are evaluating at a specific number. So it's all going to be f of 2, g of f of 4, f of g of 1, or whatever the case may be. We're looking at all at values for today. Okay, so now I'm going to find g of 7. So here's g of x. This would be 7 squared minus 4. So that's 49 minus 4, which is 45. So what is g of f of 3? It is 45. I want to make sure we're clear. There is still just one final answer here. So what is g of f of 3? It's 45. This f of 3 equals 7 is part of my work to get to that 45. And then for D, same idea, but this time I'm looking at a different order. So we work from the inside out. So I'll start with G of 3. So G of 3 means I would plug 3 in for X in my function G. We've already done this, right? We know G of 3 is 5 from part B above. So now I'm going to find F of 5. The output for my first function becomes the input for my second. Okay, so f of 5. That would be 2 times 5 plus 1. So 10 plus 1, which is 11. So f of g of 3 equals 11. Questions for me so far? Okay, it's not too bad. We're evaluating twice is really what we're doing here today. We're evaluating twice. Now, we already at the beginning of our unit practiced evaluating from a function like we did here, plug this value into this function. We also evaluated from tables and from graphs. So we're going to look at compositions, evaluating with a function, which we just did. Next, as you can see, we've got a table for example 2, and then we'll finish today evaluating composition for the graph. I want you to notice our table this time has got an extra column to it than what we looked at before. So here are my x values. And then if I plug this x, any of these x's into h, here are my y's for h, here are my y's for k. So I get that all combined in one table, okay? So we just have to be careful about what column we're looking at. So for A, 2A, we want h of k of 2. So we work from the inside out. So I'm going to start with k of 2. So 2 is my input, and I want to know what's the output for K. So I need to go over to the K column, and there's my output. K of 2 is 0. K of 2 is 0. Now I need to find H of 0. Okay, this part is 0, so I'm finding H of 0. So I'm going back to the input column, back to the X column, and this time my input is 0. I'm going to follow that over to the H column, and I get 1. So my final answer is 1. I know sometimes we don't always like to write down our full work, our steps to a problem. On the tables and graphs, please take the second to write down what you get from that inside, okay? So that when I'm looking at your work on a quiz, a quick check, a test at the end of the unit, whatever the case may be, so that when I'm looking at your work, I can see, yep, we had the right idea, evaluate inside and then outside, and I can make sure if this final answer is incorrect, I can see what you got, right? I can see your work along the way. That lets me know we had the right idea, or oops, we made a mistake in the first part. But if you made a mistake in the first part, did you do the second part correctly? That's your work, okay? That's what lets me know we're on the right track, or maybe not. For B, same idea. Start with the inside, that's H of 2. So our input is 2. I want to know what's the output for H. So that's this first column. We get -1. And now I'm going to do K of -1. So our input this time is -1. And I got to go all the way over to the K column, and I get 5 for the output. So K of H of 2 is 5. Making sense? You know where I'm getting these numbers from? C and D have that other notation, but it works the same way. So for C, start with H of 3. So 3 is my input. For H, the output is 0. And now we do K of 0. So I'm going to use 0 as my input. And I want to know if 0 is the input, what's the output for K? So I have to go all the way over to the K column, and I get 1. K of 0 is 1. And then for D, H of K of 1, we start with K of 1. So my input is 1. The output for K would be -1. And then we find H of -1. So my input now is -1. The output for H is 4. So H of K of 1 is 4. So we've done this with a function. We've done this with a table. Last on the list is compositions with graphs, okay? So if I have graphs as my representations, turn the page for me. Just like we did with our tables, I want you to write that intermediate sort of value that we get there, that kind of middleman output of the first thing, input of the second thing. I want you to jot that down for me. So I've got 2 graphs here. F of X is this guy. H of X is this guy. And it's a composition just like we've done with our tables, right? With our functions. I'm evaluating just like we did with graphs earlier in the unit. So work from the inside out. Start with F of 1. So I'm looking at my F of X graph. and my input is 1. So my x is 1. I'm going to follow that to the point on my graph and see my output is 5. So f of 1 is 5. Now I want to find h of 5. So I'm going to go to my h of x graph. We're using an input of 5, an x value of 5. Okay. I'm going to follow that to the point on my graph and give that output. Our directions do say approximate if necessary, so we've got to estimate here. This isn't at a super nice point. What's this look like to you? About negative 0.5, yeah, negative a half. About negative a half looks like to me. So f or h of f of 1 is about negative 1/2 or 0.5 if you'd rather. And then b inside is h of negative 2. So I'm starting with h. When x is negative 2, my y is negative 4. And now I have to find f of negative 4. So now we go back over to the f of x graph. And our x is negative 4. And that is the point that's on my graph. So my y value is 0. So f of h of negative 2 equals 0. Questions for me? These are a little bit more than the evaluating we did on our little quiz quick check yesterday, the other day, a couple days ago. A little bit more, got that extra step than what we worked on at the beginning of our unit. Take your time, write down that value in the middle. Okay, you'll be okay. I want you to notice at the bottom, number 6, these are your practice problems for tonight. Number 6 has 3 functions. It works the same way. Start with the inside, find g of negative 1. Then whatever you get, find f of that number. Then whatever you get, find h of that number. So we can do this with more than 2 functions as well, okay? And I want you to notice at the bottom here, you have f of x as a function, g of x as a table, h of x as our graph here, okay? So you've got these different representations that you're practicing with as you work through your composition practice problems. Okay. So those problems on the bottom are your homework for tonight. You have plenty of time to work on them and get them done and have no homework for the weekend.